All right, here is our video for LT6. We're just going over a little bit today, some vocab words and a couple practice problems. So LT6 is all about triangles. So we're going to start with some vocab words about triangles. First up, what is a triangle? A triangle is any shape with three sides. A three-sided shape. A scalene triangle is a triangle with three different side lengths. An isosceles triangle has two congruent sides. And a equilateral triangle, we even almost have the word equal in there, has three congruent, I'm going to fix that, three congruent sides. So these first vocab words talked all about the sides. So I'm even going to draw that line a little bit further across over there. This was all about the sides. So over on the right side here, let's try and classify, organize, label the triangles by how many sides they have. I guess not how many, but what we know about their sides. So just a reminder, these little dashes mean that the sides are congruent. So this one, because it has two congruent sides, so here's a reminder, here's my congruent symbol. This has to be isosceles. Three congruent sides, this one down here is going to be equilateral. And then the last one, there's nothing about the sides. I don't know if they're all the same. I don't know if they're all different. They look all different, but because I don't know, I'm going to go with scalene. So unless they tell you two are congruent, it's going to be scalene. All right, so the first vocab words were all about sides. The next ones are going to be all about angles. So an acute triangle, I think we've even had these vocab words already this year, has all three angles less than 90. A right triangle has one 90-degree angle and two acute angles. Let's make that look like an A or a U. Very similar, an obtuse triangle has one angle more than 90. That's what obtuse means. Then it has two acute angles. Finally, an equiangular triangle has three equal acute angles. So if they're all the same, they do all have to be acute for them to fit inside the triangle there. All right, just like up above, classify the triangle by its angles. So the first one, this angle is 100 degrees, so that's more than 90. So this has to be our obtuse triangle. The next one we've got this little box in the corner. So that means that's 90 degrees. So this is our right triangle. And then finally down below, 75, 75, and then this one on top is even skinnier. That is going to be our acute triangle because they're all less than 90. All right, so make sure all this vocab is filled in, and then we're going on to the next page. So some practice here. Classify the triangle by its sides. So sides, that means we're going to be talking about scalene, isosceles, and equilateral. We're not going to say anything about acute, obtuse, or right. So 3 sides that are all the same, they're all equal, we're going to put equilateral. Oh. This one, we have 2 sides of this that are the same, so I'm going to mark them with our little equal markings. So a little dash and a little dash. 2 sides that are the same, it's got to be isosceles. All right, I would like you to try the next 2. You can also check out the completed notes when you're done with the video to check how you did. But try number 3 and 4 on your own. Okay, 5, 6, 7, 8. We're talking about the angles. So this is where we'll talk about acute, obtuse, right, and equiangular. So the first one up, we've got our little right angle box in the corner. So that one is our right triangle. The next one gives us all the measures, 45, 60, 75. Those are all less than 90. So that is our acute. Once again, I would like you to try the next 2. You can check the completed notes Schoology link after this to check your work. And then let's try the next page. All right, classifying a triangle in a coordinate plane. So coordinate plane is when we have our points. I'm just going to give you a reminder. X is always first, Y is always second. So classify triangle RST by its sides. Then determine if the triangle is a right triangle. So we're going to be using 2 different things here. We're going to be using the distance formula, and we're going to be using a little bit of the slope formula. So I'm going to write our distance formula here. x2 minus x1 plus y2 minus y1. So those are both in parentheses and squared. So you might need to go grab a calculator to do this. All right, and then like I said, x is first, y is second. So on our picture, let's label, I'm going to do R and S first. Let's label this x1, y1, x2, y2. And we are going to have to kind of erase that when we do the next one because we're going to have to do the distance formula for all 3 sides. So first one up, like I said, I'm going to do RS. So x2 minus x1, my x2 is 5, minus negative 3. So when we minus a negative, it becomes a positive. And then y2 minus y1. So 5 plus 3, we get 8. and then the squared is still there, plus 2 minus 3, we get a negative 1 squared. So with negative numbers, make sure you leave them in parentheses. You will get the wrong answer if you don't leave them in parentheses. So 8 squared is 64, plus negative 1 times negative 1 is positive 1. So we get 65. Grab your calculators. The square root of 65 is 8.06. Okay, so there is our first number. Now we need to do this again, but now I'm going to do our t. So I'm going to erase my x2, y2 and write it on t instead, x2, y2. So x2 minus x1, just like before when we minus a negative, it becomes addition. y2 minus y1, negative 1 minus 3. Let me move this down. Three plus 3 is 6, plus negative 4, 36, plus 16. We get 52. And then the square root of 52 is 7.2. All right, so now I've got two of my lengths. I know I'm not going to have an equilateral triangle, but let's check that last one. So this is going to be TS, or ST, whatever you want to call it. So I'm going to erase my x1, y1 and put those over on S, x1, y1. So x2 minus x1, we have 3 minus 5. y2 minus y1, negative 1 minus 2. So negative 2 squared plus negative 3 squared, 4 plus 9, and then square root of 13, we get another decimal, 3.6. All right, so then here we've got 3 different lengths. So this one is going to have to be scalene. All right, sorry, I'm just looking ahead. So then the last part here, determine if the triangle is a right triangle. I'm actually going to hold on that one, and we can talk about that in person on Friday when I see you. So down here, we've got the same question. Classify the triangle formed by the 3 points. And I'm going to say using its side lengths. So once again, don't worry about the angles or anything. So let's start by graphing the triangle. So A is at 3, 1. I'm just looking at the scale here. So 7. I know it says 2 and 2. I'm going to make it 1 and 1. And we're just going to go a little bit off the graph. So 3, 1 is A. B is at 3, 4. 1, 2, 3, 4. And C is at 7, 1. So 1, 2, 3, 4, 5, 6, it's going to be a little bit off. So here's our 7, and then up 1. So this was B, and this is C. And so then connect those points. Let me see if I can get a straight line here. There we go. All right. So you need to find the distance of AB, BC, and AC. So using the distance formula like we did up above, and actually let me space these out a little bit. Find those 3 lengths. Then decide, is it scalene, isosceles, or equilateral? So once again, I'm going to have you try this one. You can check the completed notes, but you just need to do that distance formula 3 times. So the distance formula once more is right here. So I'm just going to kind of put it on top of our graph here. All right. So do the distance formula 3 times, get your 3 lengths, and then you can go check the completed notes to check your work. All right, topic 2, triangle sum theorem and exterior angles theorem. So a couple vocab words to start. Interior angles. So interior means inside. So interior angles are the angles on the inside of a triangle. So I know most triangles, we wouldn't even see the outside angles, but we are going to talk about those exterior angles. So that's why we've drawn the lines a little bit longer here. So interior angles are the angles inside of a shape. So today we're just talking about triangles, but interior angles are inside any shape. So a square has interior angles. A pentagon has interior angles. All right, the triangle sum theorem. So sum, remember, means addition. So the sum of the measures of the interior angles, so when I add up these 3 angles inside the triangle, it is always, always, always going to add up to 180 degrees. So if you have an equiangular triangle, an acute triangle, an obtuse triangle, no matter what kind, it's always going to add up to 180 degrees. All right, so using that information, let's try it on this triangle right next to it. So I have my 3 angles, and they're inside a triangle, so I know when I add them up, they're going to have to equal 180 degrees. So I'm going to add up x plus 3x plus 60, and that's going to equal 180. So I'm going to combine my like terms. 1x plus 3x is 4x, plus 60 equals 180. I want to get that x by itself, so I'm going to subtract 60 from both sides. 4x equals 120. And then I'm going to divide that 4 to get the x by itself. X equals 12 divided by 4 is 3, so 30. Okay, So we're going to see a lot of problems like that where you're going to have to set up an equation knowing that triangles add up to 180. So those are for the interior. Now let's take a look at the exterior. So exterior angles, it looks like there are a lot of angles outside of the triangle, but what we're going to focus on are all the ones that are outside and a little bit above. So we're not talking about vertical angles. Vertical angles would never be exterior angles. So that is an exterior angle. That is an exterior angle. And this one. Or if we went the other way, this would be an exterior angle, this one, and this one. So we kind of want to rotate around so that here on the bottom, our exterior angles aren't both on the same line. We want them, each exterior angle, to be on a different line. So exterior, the angles outside of a shape, and I'm going to make a note, not the vertical angles. So when we're looking at just one exterior angle, it doesn't matter kind of which one we do. It's only when we look at all three that we need to be careful they're not on the same line. So there's two ways to kind of find the exterior angle. So the formula they give us, this angle right here, angle 1, is equal to angle A plus angle B. So yes, that's helpful, that's useful to know, but a lot of times there might be an easier way to find that because that's a special rule just for triangles, and there's some other things we could do that might make that a little bit easier. Just filling out what's on the line here. The measure of an exterior angle of a triangle is equal to the sum of the measures of the two remote interior. And what they mean by remote, they mean not the one right next to it. So I wouldn't include this angle C that's right next to the exterior angle. So our example over on the right, if we remember this rule, we could just say x equals 64 plus 70. Add those up. And we get x equals 134. So that works. But I think by the end, most of us will actually end up doing this in 2 steps. So first, let's think. We know that triangles have to add up to 180. So to find this little angle right here, I could just subtract the angles I already know. So 180 minus 64 minus 70. And we get 46. Well, now I've got this angle right here is 46, and this is my x. So that's kind of this picture right here. Well, let's think back. How many degrees are in a straight line? So most of us, we've done this is a linear pair. We've done linear pairs before, so this might be a little bit easier for us. Linear pairs, 180 is going to be equal to that 46 plus x. So just get that 46 out of there. And 134 equals x. So we get the same answer either way. I know some of you really struggle to remember different rules. And instead of having to remember this one rule, it's remembering some things we've already learned and we've already worked on. All right. Sorry, I'm just going to peek ahead. We're just going to do a couple practice problems here, and then I'm going to have you do a couple, and then we're done. All right, so 11, yeah, well, maybe you do 11, 14, 24 here. So 11. We know that the triangle is going to add up to 180. Ooh. I've got this angle right here that's 90 degrees. So 90 plus 2x plus x equals 180. Combine our like terms. 90 plus 3x equals 180. Minus 90, minus 90. I did not give myself enough room. I'm going to sneak this over here. Three x equals 90. Divide by 3, divide by 3. X equals 30. So we've got 30 in this corner, 60 in this corner. So if I classify this by its side, this is sorry, not by its sides, by its angles. This is a right triangle. All right. So the second one, I'm not going to solve all the way, but the same idea. Add up the three angles. 3x plus 2x plus 55 equals 180. All right, now I would like you to solve that one. 14. Find the measure of the exterior angle shown. So this one, they want us to use that rule we just talked about, where when I add up these two, it equals this exterior angle. So 80 plus x equals 3x minus 22. I'm going to subtract that x. 80 equals 2x minus 22. I'm going to add 22. And once again, I need to start higher on these. So 2x on this side, 80 minus 22. I've got 58. Divide by 2, divide by 2. X equals 29. So I know what x is. Go back and read the directions. Find the measure of the exterior angle shown. So to find the measure of the exterior angle, I need to plug in 29 for this x. So 3 times 29 minus 22. 3 times 29, we get 87, minus 22, we get 65. So this angle right here is 65 degrees. Okay, 15 and 16, the same idea. So I'm going to set up 16. Partly, I just don't have space for 15. So I'm going to add up the two angles on the outside. 2x plus 103 minus x. And that equals 6x minus 7. All right, now find that and find the measure of the exterior angle. You're going to have to plug it back in to find how much is that whole angle. All right, the challenge problems. So I will do both of these ones just so we can kind of see these harder ones. Find the values of x and y. All right, so I'm going to do just one triangle at a time. So I'm going to start with this little guy over here. Whatever. So I know that this corner is 90. So 90 plus 39 plus y equals 180. So I'm going to add up that 90 plus 39, combine my like terms. 129 plus y equals 180. Minus the 129. Y equals 51. All right. So this right here is 51. I just don't have enough room for everything today. So I'm just going to kind of move that out of the way as I keep going here. So this angle is 51. This angle up here is 50. Can I find this angle right here? Well, these three together make a straight line. And we know that straight lines are 180. So 180 minus the 51 minus the 50. 51 and 50 is 101. Leaves me with 79. So this angle right here is 79. And now, same thing I kind of just did, 180 is going to equal those three angles together, the x and the 56 and the 79. So 56 plus 79 is 135. And so 180 minus 139 is 45. Okay. All right, last one we got here. So 25. We want to find x and y. So x is this skinny little angle up here, and y is this one down here. So first thing I see is in this big triangle, I know two of the angles. So I can just figure out the other one by subtracting from 180. 180 minus, oh, not 108, 180 minus 74 minus 70 is 36. So this angle in this corner is 36. So now, kind of what I showed over on the other side too, and I'm going to draw it a little bit bigger. Let me make it look a little bit more like our picture. So this angle we just said was 36. This angle they told us was 78. Now, when three angles together make a straight line, well, straight lines are always 180. No matter if it's broken into three angles or if it was broken into like 6 angles, all these together would still have to be 180. So I know I can find this angle, this is y, by using our 180 for straight lines. So all three of these angles together have to equal a straight line. So 36 plus 78, y plus 114 is 180, minus that 114, y equals 66. All right, so back on our big picture, this angle, I'm going to zoom way in, is 66. And now in here, I've got this smaller right triangle. So let me draw a bigger version of that as well. So it's kind of slanted, but then I've got a right angle here, 66 degrees here, and this is my x. So because it's a triangle, x plus 66 plus the 90 degrees is 180. Oh, not equals, x plus, combine like terms, 66 plus 90, we get 156 equals 180. Subtract that 156, 180 minus 156, and we get 24. All right, so here's my y, here's my x, and there we go. So please check the completed notes on this page and that other example page. See how you did on these practice problems, and then start on your homework assignment. So your homework, I believe I said 1 through 20 up on the board. If you can just keep working on that until the hour is done, that is great. Thank you, and see you guys on Friday.